For decades, we've searched the stars not only for new planets or strange signals, but for something rarer. The moments when the universe breaks its own rules. The moments that make even the most logical minds fall silent. Now, the James Webb Space Telescope has captured one of those moments. What began as a routine observation of an interstellar object has turned into the kind of mystery that redefines everything we think we know about what moves out there. It started with a faint object moving slowly through the outer solar system, a blur of light so small it barely stood out against the black. Astronomers called it 3I/ATLAS, the third confirmed interstellar visitor in history, a traveler from beyond our sun's reach. Like the others before it, it was expected to be simple, cold, predictable. Just another ancient piece of rock flung across the galaxy, drifting without purpose. But from the beginning, something about 3I/ATLAS refused to fit. Its light was wrong. Normally, comets brighten unevenly as sunlight melts their icy surfaces. They flare, they fade, their glow dances chaotically. But 3I/ATLAS didn't flicker. It shone with impossible stability, bright enough to outshine larger bodies, yet constant, unwavering, as if powered from within. The brightness didn't match its estimated size or composition. It wasn't reflecting sunlight the way a comet should. It was emitting light, clean, steady, unnatural. Telescopes across Earth turned toward it, and when the James Webb Telescope, floating 1,000,000 miles from our planet, finally focused its golden mirrors on that small patch of darkness, the truth came into view. Inside the dust and silence of 3I Atlas, Webb detected something it shouldn't have. A glow. Not just scattered reflection, but radiated heat, light that came from within the object itself. Natural objects don't do that. Every comet shines because of sunlight. Every asteroid glows from friction or reflection. But the light inside 3I/ATLAS pulsed faintly, irregularly, cycling in intervals that repeated every few hours. It wasn't the chaotic sputtering of a comet venting gas. It was patterned. It was rhythmic. It was precise. The first theory was radioactive decay. Maybe some exotic isotope deep within the rock was generating heat, but the energy curve didn't match. Then scientists proposed internal friction from a spinning core, like a gyroscope of ice and stone grinding against itself. That too collapsed under analysis. The pattern wasn't random motion or heat loss. It was controlled release, a rhythm repeating too perfectly to be natural. For days, the Webb telescope recorded those pulses, mapping every beat. Each time, the energy spiked across a narrow frequency band, light emitted at wavelengths that had no place in the natural spectrum of comets or asteroids. It was a focused emission, as if something inside was adjusting its output, fine-tuning itself. When the spectral data came back, what Webb found silenced the room. The emission line wasn't broad like a reflection. It was narrow, targeted, a single thin band of light matching the kind used in modern optical communication. In other words, it looked manufactured. For the first time, the data pointed to something no one wanted to say aloud. 3I/ATLAS might not be a rock. It might be a machine. At first, no one dared to publish. The explanations that followed were predictable. Experimental error, instrument drift, data contamination. But the numbers held. The light was real. The pulse was real. And buried inside that faint rhythmic glow was something stranger still. Modulation. When the data was plotted as an audio waveform, the light pulses weren't identical. Each carried tiny variations structured like the beats of a signal. Not random interference, not solar static, encoded information. Scientists at MIT and Harvard ran Fourier analysis on the data to isolate the frequencies. The results revealed a repeating cycle: 12 long pulses, 3 short ones, and then silence. No natural process behaves that way. It wasn't binary, not exactly, but it was unmistakably deliberate. Some called it telemetry, a data stream. Others called it a beacon. A few whispered something worse, a distress signal perhaps sent long before our species ever existed. Meanwhile, the more Webb watched, the less 3I Atlas looked like anything natural. Its orbit through the solar system was too precise. Objects from deep space usually drift, pulled slightly off course by planetary gravity. But 3I/ATLAS corrected itself, subtly, almost invisibly, maintaining a perfect trajectory as if it was aware of its own balance. Even its rotation was wrong. Most comets tumble unevenly, spinning end over end. This one turned smoothly on a single axis, like a stabilized craft. And when it passed near sunlight, it didn't form a tail. No dust, no vapor, no melting ice. Instead, its light intensified, as if feeding off the star's energy. One of Webb's instruments, designed to track thermal gradients, registered something extraordinary. As 3I/ATLAS neared solar exposure, its surface didn't heat chaotically. The temperature rose evenly across the entire structure. That shouldn't be possible unless heat was being managed. Distributed, controlled. When the data was published internally, one scientist wrote a single note in the margin. This object is powered. The implications hit the astrophysics community like a shockwave. If the object was metallic, hollow, and producing controlled emissions, it wasn't a comet. It was technology, but no one would say it out loud. Emails leaked between NASA, ESA, and the Japanese Space Agency suggested quiet coordination. A small team was tasked to study the non-natural optical behavior of 3I Atlas. Behind closed doors, the words they used were more direct: propulsion, containment, activation. Then Webb's photometric instruments detected something chilling. The light coming from 3I/ATLAS wasn't random or diffused. It was concentrated in a narrow beam, shifting direction slightly over time. A beam. The narrow wavelength was within the same range Earth uses for the long-distance laser communication, between 1,500 and 1,600 nanometers. The intensity fluctuated slightly whenever sunlight hit it, like a system responding to power input. In human terms, it looked like calibration. As data continued to stream in, the light began flickering in intervals of seconds, then fractions of seconds, too fast to be random. Mathematicians modeled the timing and found ratios aligning perfectly with prime numbers: 2, 3, 5, 7, 11. Every pulse, every flash carried intention. It wasn't just shining, it was transmitting. The Webb team reran every model, every hypothesis. They cross-checked with solar winds, radiation noise, cosmic rays, but the numbers stayed locked in place. No natural explanation fit. And that's when a quiet message went around the scientific community, one that never made it into the public briefings. We're not looking at it. It's looking at us. 3. Atlas wasn't drifting through our solar system by chance. It was aligning, slowing, orienting, positioning itself in perfect resonance with our star, as though waiting for something. And as the pulses continued, the James Webb Space Telescope kept watching. Each flicker of light wasn't just illumination anymore, it was communication. And whatever it was trying to say, it was still saying it. The data from 3I/ATLAS kept coming, and with each transmission, the mystery deepened. At first, astronomers thought the pulses were random cosmic interference, but the more they analyzed them, the more deliberate they became. Every flicker carried structure, intervals, spacing, mathematical symmetry that defied chaos. The light wasn't behaving like a reflection or even like an emission. It was acting like a language. The James Webb Telescope wasn't just seeing light anymore. It was receiving a signal. When researchers slowed the data stream to 1,000th speed and plotted the wavelengths across time, a pattern appeared. Not just repetition, but recursion. The same sequences repeated at different scales, fractal-like, mirroring themselves across frequency bands. It was as if the light itself was thinking. For days, the world didn't know. Inside the Webb Control Center, everything was locked down. Only a handful of scientists had access to the raw data. Even NASA's public feed went silent. What had begun as a simple observation had become something else, a classified event. And then, quietly, the leak happened. A whistleblower inside the European Space Agency released fragments of the unfiltered photometric data online. Amateur astronomers around the world began comparing it with their own readings of 3I/ATLAS, and together they uncovered the impossible truth. The pulse intervals weren't random. They matched a mathematical sequence known as the Golomb ruler, a pattern used in digital communications to avoid interference and data overlap. It was the same kind of structure engineers use in radar and laser encoding. This wasn't a natural phenomenon, it was an engineered transmission. The news spread fast. Scientists, conspiracy theorists, and military analysts flooded the networks with interpretations. Some believed it was a message, others thought it was telemetry from a damaged probe. Ancient, self-guided, and still trying to report home. But one group of astrophysicists at Caltech found something deeper. The light wasn't just structured, it was responsive. When Webb briefly lost line of sight during a solar calibration maneuver, the pulse frequency changed. It slowed slightly, as if waiting. And when the telescope reoriented and re-established contact, the pattern resumed, perfectly aligned with the time delay caused by the maneuver. It had noticed. Something inside 3I/ATLAS was aware of being watched. That's when the object's rotation began to shift. Previously, its axis had been stable, a slow spin, steady, and mechanical. Now the data showed subtle corrections, tiny adjustments in its roll. It was orienting itself, aligning one side directly toward the telescope's position. Webb's imaging systems captured faint glints of light from its surface, sharp, linear reflections that didn't look like natural terrain. When the spectrum of those reflections was analyzed, it revealed trace signatures of elements that shouldn't exist in a comet or asteroid. Titanium alloys, vaporized aluminum, and crystalline carbon, materials used in high-energy containment and optical engineering. 3I/ATLAS wasn't a rock. It was built. NASA's internal documents began referring to it as the structure. No longer an interstellar object, but an engineered entity. Its behavior grew stranger with every hour. The light pulses became faster, more refined. They weren't simple bursts anymore. They were layered modulations. Carrier waves inside carrier waves, a form of multiplexing far more advanced than anything humanity had achieved. Someone suggested trying to respond. Using Webb's infrared sensors, engineers generated a reply, a short, controlled pulse of light mimicking the rhythm of the object's last transmission. The signal was transmitted toward 3I/ATLAS through secondary observatories, with Webb acting as the receiver. For 13 hours, there was nothing. Then, just as everyone began to lose hope, the pulse changed again. It mirrored our response exactly, then added to it. What had been 12 bursts before now became 13. The object had acknowledged us. For the first time in human history, contact had been made. The rhythm continued for days, building in complexity. Each time humanity replied, the signal evolved. Patterns within the light began forming geometric relationships, angular symmetries that mirrored shapes seen in gravitational physics, spirals, ellipses, arcs. Every time the data was plotted, it resembled orbital maps, as if the light was describing trajectories through space. The more we observed, the more one thing became clear. This wasn't random communication. It was guidance. 3I/ATLAS was transmitting coordinates. The data pointed to a location, not deep in space, but within our solar system. When astronomers overlaid the coordinates onto orbital charts, they realized it was pointing directly toward a position near the asteroid belt, an empty region of space that, at first glance, seemed meaningless. But then they checked older records. That same location had once been occupied 46 years ago by a passing object. Voyager 2. It wasn't possible. Voyager 2 had long since moved far beyond that point, but the timing matched perfectly with the year of its launch trajectory. 3I Atlas was pointing to the exact spot in space where humanity's first interstellar probe had once been. It wasn't a random message, it was a memory. Then, the lights inside the structure changed. They didn't just pulse anymore, they began to flow. Beams of soft blue light moved beneath the surface, circulating in patterns like veins. Thermal imaging showed that these channels were heating rapidly, like power systems charging. When Webb sensors measured the luminosity, it wasn't consistent with chemical reactions or radiation decay. It was steady, coherent, the same profile produced by laser excitation. Whatever was inside 3I Atlas was waking up. That's when the object changed trajectory. Without any visible propulsion, without any jet or plume, it began to drift off its original path. The motion was slow but precise. Every calculation showed that it was adjusting itself into a new orbit, one that would bring it closer to the inner solar system, closer to Earth. The correction couldn't have been caused by gravity or sunlight. The forces involved required guidance, active control. Within 72 hours, every major space agency stopped sharing telemetry data. The official explanation called it optical interference. But leaked internal briefings confirmed what everyone feared. The object was moving with purpose. Even more alarming, its rotation had synchronized with our planet's position relative to the Sun. Every time Earth completed a rotation, the object's alignment corrected by the exact same amount. 3I/ATLAS wasn't drifting anymore. It was tracking us. And then came the final transmission. For a brief moment, the light inside the object flared to its brightest recorded state. Webb's instruments almost overloaded from the intensity. In that moment, the pulses disappeared, replaced by a single continuous beam aimed directly at Earth. The wavelength was perfectly safe, infrared, invisible to human eyes, but the signal contained one last data pattern. When decoded, it revealed a simple mathematical design, a spiral divided into segments of precise ratios. The same ratio found in the human genome. It wasn't just looking at us, it was recognizing us. The light from 3I/ATLAS no longer flickered. It burned steady, unwavering like a single eye in the dark. What the James Webb Space Telescope recorded in the following hours would leave the entire team staring at their monitors in silence. For weeks, the light had pulsed in sequences, rhythmic bursts, encoded harmonics, patterns that could be measured, studied, understood. But now, the glow inside the object began to change color. Slowly, deliberately, it shifted from white to deep crimson, then to a wavelength invisible to the human eye. Webb's instruments caught it all, infrared radiation fluctuating in a perfect mathematical pattern. When scientists translated those fluctuations into sound, what they heard wasn't random static. It was a rising hum, a tone that vibrated at 432 hertz, the same resonance used in ancient tuning systems, the same frequency found in the vibration of our planet's magnetic field. At first, the hum was faint. Then, as the hours passed, it intensified, strong enough to interfere with communications at the deep space network. The object wasn't just emitting light anymore, it was broadcasting. When researchers analyzed the encoded signal, it wasn't like anything seen before. The waveform wasn't linear. It folded over itself, recursive and endless, like a spiral folding into its own center. When plotted visually, the data resembled an eye, a perfect ellipse surrounded by radiating waves of symmetry. The energy wasn't escaping into space. It was being shaped, focused, directed. And then, Webb detected a reply. Not from Earth, not from another telescope, but from space itself, millions of kilometers away, somewhere between the orbit of Mars and Jupiter. A faint echo pulsed back, perfectly synchronized to the original emission. At first, it looked like simple reflection, but the return signal was stronger, amplified, like it had been answered. Whatever was inside 3I/ATLAS had reached out, and something out there had reached back. The two signals began to alternate, forming a pattern of call and response that lasted for exactly 17 minutes. Then, both fell silent. When Webb's imaging systems refocused, the structure inside 3I/ATLAS had changed. The internal light wasn't random anymore. It had condensed into linear shapes, grids, and angles too precise to be natural. What had once looked like an icy mass was now a network of straight lines glowing through the haze, forming geometry that resembled circuitry. The object wasn't breaking apart, it was reconfiguring. Spectral readings showed metals within the core shifting molecularly as though being rearranged. Silicon, aluminum, nickel, all bending to invisible forces. It wasn't decay, it was construction. And then, everything stopped. The light vanished, the object fell dark. For the first time since Webb had begun its observation, 3I/ATLAS was completely invisible. No infrared, no thermal radiation, no reflected light, just void. But within that void, something began to move. For nearly 4 hours, Webb's deep imaging sensors tracked faint distortions, shadows bending light itself. At first, it looked like gravitational lensing, the kind caused by black holes. But this wasn't gravity. It was localized, controlled. Whatever 3I/ATLAS had become, it wasn't inert anymore. It was active. Telemetry from NASA's secondary tracking systems showed a slight increase in the object's velocity. It was accelerating, not fast, but steady, and not outward, inward, toward the inner solar system. The path wasn't random, it was deliberate. The object had plotted a trajectory that would take it past Mars within observational range of Earth. The math was simple, the result chilling. In less than 7 months, 3I/ATLAS would make its closest approach to our planet. That's when NASA classified every file under the Omega contingency. The Webb team was ordered to shut down direct observation, and all public feeds related to the object were erased. Official statements described it as a disintegrating comet with unstable thermal output. But behind closed doors, no one believed that, because days after the signal went silent, new data began appearing. Signals that didn't come from Webb or from any known transmitter. All around the world, radio telescopes picked up faint repeating pulses in the same pattern that 3I/ATLAS had used. The signals weren't coming from space anymore, they were coming from Earth. Amateur radio operators from Argentina to Japan began recording identical transmissions, all broadcasting at the same wavelength the object had emitted. The pulses carried the same recursive pattern, the spiral, the prime number intervals, the encoded harmonics. It was as if the message had infected our planet's electromagnetic field. Every attempt to isolate the source failed. The signals didn't come from towers or satellites. They seemed to emerge from the atmosphere itself, as though the planet were repeating what it had heard. The same hum that had started light years away was now vibrating through our ionosphere, and then one final image came from Webb, its last observation before its systems were reprogrammed. In the data archive, frame number 5572, the object could be seen faintly glowing again. The light wasn't chaotic this time. It was clear, focused. The shape of the light, seen from tens of millions of kilometers away, matched the silhouette of Earth. 3I/ATLAS wasn't sending a message anymore. It was sending a reflection. When the Webb engineers filtered the image, a faint spectral line became visible beneath the glow. An inscription, almost invisible in the data. It wasn't random interference. It was writing, 3 short symbols, repeating. When converted into binary, they spelled one word: awake. After that, the object fell completely silent. No light, no pulse, no reflection. And yet, telescopes across the world continued to pick up faint echoes, tiny electromagnetic ripples synchronized perfectly with Earth's own magnetic heartbeat. It wasn't gone. It had simply blended in. No one knows if 3I/ATLAS is a probe, a signal, or something older than both. But what James Webb saw inside it, the light, the pulse, the transformation, changed everything we thought we understood about interstellar visitors. Because whatever it is, it didn't just pass by us. It found us. And now, every few weeks, the same faint hum Webb once heard out there appears again on our own instruments. Faint, familiar, and always aligned with our orbit, as though something out there is still watching, still waiting, still awake. And every time the signal rises just above the noise, scientists can't help but ask the same question. What if 3I/ATLAS wasn't trying to communicate at all? What if it was trying to wake us up too?